Assalamualaikum and greetings to everyone. So my name is Haslisa Fatiah Binti Hasnan, and the title of my final year project is a systematic review of extraction and characterization of oleic acid, also known as omega-9 rich Camellia japonica oil. For the introduction part, let me tell you a bit on the Camellia japonica flower, which you can see in the picture. So for some background, Camellia japonica belongs to the family genus of Camellia, Diaceae, and is cultivated native in Asia and can even be found in Malaysia. When the oil is extracted from usually the seed, it is one of the oil that has high concentration of oleic acid and low saturated fat, which is an healthy alternative of oil. It has been widely used in Chinese herbal and even medical area as it has been proven to be effective. As it is rich with oleic acid, which is a monosaturated omega-9 fatty acid that is found in various animal and vegetable sources. It is also very useful as oleic acid can be used in skincare for moisturizing, for hydration, and it even helps to heal and repair our skin. Oleic acid can also be used in the medical area as it has an anti-inflammatory properties. Next, as Camellia oil has a high market demand, the most common extraction method is a bit worrying as it usually uses hexane-based extraction method or even a combination process of expeller pressing and hexane-based extraction. So this method will cause some concern on the safeness and the environmental effect because we know that hexane is hazardous if it is not handled properly. Hence, there is a need to find a more greener extraction method. So for the objective of this research, it is to identify green extraction method, and next is to compare between those green extraction method based on their percentage of oil yield. And finally, it is to characterize the oleic acid in the extracted oil by looking on the composition of the oleic acid in the oil. So the scope of this research is that all of the data and information are extracted from journal article, etc. And then critical review are added based on my opinion. Next, I will explain the methodology of writing this systematic review paper. First, I had discussion with my supervisor and the PhD student on the topic and how to go from there. Then the keyword is decided, which is the extraction method and the physiochemical of the oil. Hence, to find the reference, I had to type the keywords on several different portals such as Google Scholar, Science Direct, etc. And then, based on the title and the abstract of the paper, I categorized them whether it is relevant or not. Moving on, I extracted the relevant data or information that I need to write the paper. So, until now, the reference I have based on is nearly 30 paper, and finally, I can start to draft the systematic review paper. The result from my research is that there are three green extraction methods, which is aqueous enzymatic extraction method, supercritical carbon dioxide extraction, and the steam explosion extraction method. So for the first method, I have found out that the oil yield differ from when using different enzyme. So as you can see, when protease is used as enzyme, the oil yield is at 63.87%. But if cellulase is used as the enzyme, the oil yield is reduced to 61.25%. However, if both protease and cellulase are used together as enzyme, the oil yield can be increased. Also, by using gas chromatography, the oleic acid composition in the extracted oil is nearly at around 81%. For the next method, which is the supercritical carbon dioxide extraction method, the oil yield is the lowest comparing to other methods, which is at 54%. So the oil yield can be increased by adding the ethanol, but the color of the oil will turn darker, possibly because of contamination. And the oleic acid composition is also at the lowest comparing to other method, which is only at 49.4%. The final method is the steam explosion extraction method, which has the highest oil yield of 86.56% at the pressure of 1.6 megapascal. However, as the steam pressure increases over 1.6 megapascal, the oil yield will decrease marginally. Also, the composition of oleic acid is also at the highest comparing to other methods. The composition of the oleic acid is at 81.05%. As you can see in the graph, it shows that the effect of steam explosion pressure on the oil yield. So as mentioned before, the highest oil yield is when the pressure is at 1.6 megapascal. And as you can see, from 0 megapascal to 1.6 megapascal, the oil yield is gradually improved. This is due to the fact that in some pressure range, steam explosion could destroy the cell thoroughly and enhance the porosity, which will release the oil surrounded in the cell and decrease the oil in the seed cake. But however, after 1.6 megapascal, the yield drops slightly for higher steam pressure. Also, if you can see from the table 1, we show the fatty acid composition of camellia seed oil that is obtained from steam explosion and it is untreated. You can see that the oleic acid has the highest percentage of the composition, whether it is at 0 megapascal or extracted at 1.6 megapascal. So at 1.6 megapascal, the oleic acid composition is at 81.05%, and at 0 megapascal, it is at 79.16%. From the table, we can conclude that oleic acid is indeed has the highest composition in camellia oil, and that camellia oil is indeed rich in oleic acid. To conclude, the steam explosion extraction method has the highest oil yield comparing to the other method, which is at 86.56%. Hence, the high percentage shows promising potential for green alternative extraction method comparing to the conventional extraction method, which involve hexane, which is, as we know, is hazardous. Also, the characterization of the extracted oil also shows high percentage composition of oleic acid, which definitely proves that camellia oil is indeed rich in oleic acid. So for future recommendation, maybe we can try to further isolate and purify the oleic acid from the extracted oil for other industry uses. This is the list of reference that I use for the slides. And that is all from me. Thank you very much for listening.